After years filled with mystery, speculation, and countless astronomical theories, the universe has finally unveiled one of its best-kept secrets. The James Webb Space Telescope, humanity's most powerful eye in space, has captured something extraordinary, something that may alter our perception of the cosmos forever. For the first time, we have a real high-resolution image of Betelgeuse, a colossal and enigmatic star that many believed was on the verge of a cataclysmic explosion. But the image that arrived was far beyond what anyone anticipated. What exactly did we see? Was this simply a glimpse at a dying star? Or were we witnessing a phenomenon never observed before, possibly hiding something even more profound? Betelgeuse has long held a special place in the study of the stars. Towering in the Orion constellation, this red supergiant has captivated astronomers for generations. Its sheer size is staggering, about 1/400 times larger than the Sun, and its reddish glow makes it one of the most easily recognizable stars in the night sky. But beyond its beauty lies a star shrouded in curiosity and suspicion. Scientists have watched Betelgeuse with fascination, partly due to its extreme scale, but also because of its increasingly unpredictable behavior. In recent years, Betelgeuse began to do something strange. It started to dim, and not just slightly, its brightness dropped significantly and quickly. For a star that had always shone so consistently and vividly, this sudden dimming was unexpected. It was so dramatic that it sparked a frenzy in the scientific community and among space enthusiasts. Was Betelgeuse nearing the end of its life? Could we be on the brink of witnessing a supernova, a rare stellar event visible from Earth? The excitement was palpable and speculation spread like wildfire. Some believed the explosion was imminent, possibly just days or weeks away. Others suggested that something more mysterious was at play. The sudden drop in brightness led to an intense period of study. Telescopes all over the world focused on the star, and data was gathered as scientists tried to understand what was happening. A supernova in our own galaxy would be unprecedented in modern human history. It would light up the night sky like a second sun and remain visible for weeks, maybe even months. Despite the anticipation and the theories, the star didn't explode. It simply kept fluctuating, refusing to follow the expected path. That's when the James Webb Space Telescope entered the picture. A triumph of modern engineering, this telescope was built to peer deeper into the universe than ever before. It's equipped with a gold-plated mirror spanning over 6 meters in diameter, allowing it to collect faint light from the most distant and ancient corners of space. While its primary mission is to observe the early universe and distant galaxies, Webb also holds the potential to answer more local cosmic questions, like the mystery surrounding Betelgeuse. When Webb turned its powerful infrared sensors toward the red giant, the results were astonishing. The telescope captured the first real detailed image of Betelgeuse's surface. What it saw was not a dim, dying star, but a celestial body alive with turbulent activity. Rather than fading into silence, Betelgeuse was erupting, blazing with intense heat and throwing off vast clouds of gas and dust. These dramatic ejections weren't just minor outbursts. They were massive, violent events on a stellar scale. On its surface, Betelgeuse displayed hot spots and large, bright regions that had never been seen before. These were not static features. They shifted, grew, and dimmed over the course of weeks, giving the impression of a star in constant chaotic motion. This pattern of brightening and dimming, far more erratic than previously understood, was unlike anything astronomers had witnessed in a supergiant of its kind. These changes weren't merely surface fluctuations. They appeared to be the result of explosive activity deep within the star itself. The images also revealed a thick cloud of matter surrounding Betelgeuse, material the star had ejected during its turbulent episodes. This cloud of gas and dust may have been what caused the star's apparent dimming when observed from Earth. In other words, Betelgeuse wasn't dying when it appeared to fade. It was shedding its outer layers in spectacular fashion. These eruptions are known as stellar mass ejections, and they're capable of launching enormous quantities of matter into space. For Betelgeuse, these events seem to be happening more frequently and with greater intensity than anyone had anticipated. This revelation triggered a new wave of theories among astrophysicists. Was the star entering its final, most unstable phase, or was it going through a period of dramatic but ultimately survivable instability, a kind of stellar tantrum before regaining balance? No matter the answer, one thing was certain. Betelgeuse was not behaving the way scientists expected. Its unpredictable activity defied previous models of how massive stars age and die. For years, we thought we understood the final stages of a supergiant's life. Betelgeuse is now forcing astronomers to rethink those assumptions. It's showing us that the process might be far more chaotic and complex than we believed. The implications of this discovery are vast. If Betelgeuse were to go supernova, the event would be visible from Earth with the naked eye, possibly even during the daytime. It would shine like a second sun in the sky, a dazzling spectacle visible for weeks. Fortunately, even at such close astronomical range, about 642 light-years away, it wouldn't pose any threat to our planet. But it would be a monumental event for science. A nearby supernova could provide an unprecedented opportunity to study the mechanics of these explosions in real time. More importantly, such explosions are fundamental to the very structure of the universe. Supernovae are responsible for dispersing heavy elements like carbon, oxygen, and iron into space. These are the building blocks of planets' atmospheres and life itself. In fact, every atom of oxygen you breathe and every carbon atom in your body was created in the heart of a dying star. Observing this process up close could give scientists new insights into the origin of the elements that make life possible. So, in many ways, watching Betelgeuse evolve is like watching the cosmic cycle of life and death play out in real time. It connects us to the stars in a tangible way. As we look at this distant red giant, we're reminded that we come from the same material, that the death of a star is also the beginning of something new. The James Webb Space Telescope has already changed our understanding of Betelgeuse, but this is only the beginning. Its mission is far from over. As it continues to scan the skies, it may uncover more surprises, whether in the form of other dying stars, new planetary systems forming, or even potential clues about life beyond Earth. Each observation adds a piece to the puzzle of our universe, rewriting textbooks and expanding the limits of what we thought was possible. The story of Betelgeuse isn't just about a star, it's about our desire to understand where we came from and what lies ahead. The more we learn, the more we realize how little we truly know about the cosmos. And that's the beauty of exploration. The universe is alive with mystery, and for the first time we have a tool powerful enough to lift the veil. What we're witnessing now with Betelgeuse might just be one chapter in a much larger story, one that will continue to unfold in the years to come. Every discovery from the James Webb Telescope reminds us that we are part of a vast, interconnected universe. And sometimes all it takes is a single image to change everything.